Hey everybody, Corey and Victoria here. We are the Professors Du Bois, and in this lecture we're going to talk about a very specific type of reaction that's really pretty cool. One of my favorite types of reactions, and it's called a precipitation reaction.
Precipitation, not precipitation, which we see a lot. Precipitation, kind of like snow and rain. So when you mix two solutions together, sometimes you form an insoluble solid. So you can see this droplet of clear liquid being dropped into another clear liquid, and we're forming a solid, and it can kind of rain or snow down to the bottom of this test tube here, and that's why they call it a precipitation reaction. So chemical reactions, we're going to be talking mainly about aqueous solutions in this chapter, and if when you mix two things together, one of the products is either a pure solid, a pure liquid, or a gas, that drives the reaction forward. So we call it a driver for a reaction. And precipitation is one of those, and that forms a solid.
And I think it's probably one of my favorites because you can it's a very visual thing that you can see, and sometimes you get some really neat colors. It's really quite spectacular.
Yeah, this yellow probably has some type of lead in it. So it's maybe a lead chromate or something. So drivers are, sometimes you can mix two things together and nothing happens. So that would mean that we don't have a driver for the reaction. We don't have something that is, sometimes a solid can disappear. That's another driver for a reaction. But right now we're going to be talking about the driver of forming an insoluble substance. So we're forming a solid. Whoop. I don't know why I did that.
Could be trouble.
Ooh, hello. There we go. Okay.
So precipitation. This is where a solid is formed from a solution. So we can call this solid a precipitate. You'll see that word. Often a double replacement reaction, remember we talked about these before, will form an insoluble compound. So we've got an example here. These aren't actual compounds, but we've got a double replacement or double displacement. And so what that means is I like to just think that the cations are switching. So the A, that's going to be the cation from AB, is going to go with the D. And the C is going to go with the B. Now, if we look at the states written down subscript to the right, we've got AB is aqueous, CD is aqueous. So these are solutions in water. And when we mix these, we form AD, which is aqueous, but look at this CB, that's got the solid. That's a precipitate, so this is a precipitation reaction.
In order to determine, when you do your double replacement reaction and form your products, you're going to have to use your solubility table for your ionic substances to see if it's a solid. So in order to determine if something is a precipitation reaction, you would perform the reaction, make your products, and then from that you can look at your table to see if it is a solid. If it's an acid, it's always soluble.
And we can do this right on paper. So let's see an example here. We can be given a couple of reactants. We've got lead nitrate and potassium sulfate. Notice they're both aqueous. So we are gonna predict the products. Now, because we have two compounds here, we can use the double displacement type reaction to predict our products. And the way we like to do this is we like to take each compound and break it into its ions, and we write them up above. And this is just to help us, because remember I was saying I like to switch the cations? So this kind of helps us see the cations and see the anions. Now, you might be looking at this and be like, well, wait, the lead nitrate has two nitrates. You only wrote one. Well, lead nitrate has two nitrates because the lead has a 2+ charge. So we're not really concerned with how many right now. We just want to know how are these going to combine to form products. So if we do this approach of switching the cations, I can say, okay, so lead, instead of going with the nitrate, is now going to go with the sulfate. Now, sulfate has a 2- charge, and lead has a 2+, so these combine in a 1-to-1 ratio, and it's just PbSO4. Likewise, the potassium, make sure the metal comes first, is going to combine with the nitrate in a 1-to-1 ratio. So we're going to have to balance this equation. why don't we do that now? So I like to, I see I've got polyatomic ions here on both sides with the nitrate. There's 2 on the reactant side. Let's put a 2 in front of the KNO3, and that'll give us 2 of the NO3s on the right. We've just balanced the nitrate. So the lead looks good. I've got 2 potassiums, 1 sulfate. We're balanced just with the 2. So the next step is to go, because we have ionic compounds, right? And these were aqueous solutions. We're going to go to our solubility chart and we're going to look these up. Now, let's start with the lead sulfate. So the sulfate is the lead ion, is the anion from that compound. We want to start with that, and that falls in the soluble category, but we have to check those exceptions and take a look at that. Lead is an exception. So even though the sulfate compounds are usually soluble, not this time. It's an exception with the lead. So instead of writing AQ, we put an S, and that means solid. And that's a little bit weird. Insoluble, we write S. But
it's unfortunate, but it means solid.
It means solid. So we should do our due diligence with the potassium nitrate. So I'm going to look for this nitrate. I see it up at the top. It is soluble. And what about the exceptions? There are none. All of the nitrates are soluble. And you know what? Those anions that are always soluble, it's kind of nice to memorize those. It'll really speed you up in this process. If you knew that all nitrates are soluble, you wouldn't have to look that up. So there's a shortcut.
So this is considered your complete molecular equation. And we're going to have a couple different types of equations. This is the complete molecular equation. So all the molecules are there. In this case, they're ionic substances. But it's really important that you form the correct formula. And you don't you don't put K2 something just because there's 2 over here. That 2 ended up being a coefficient. So it's really important for you to identify what the ions are before you try to combine them into a new formula.
And another thing worth mentioning is, we wrote those ions up above, and once you form your products, you want to either cross those out or erase them. You don't want your professor to think you don't know what the heck you're doing with these up there. You just, you want to make it clear that, those were just notes for you to help you combine and form your products.
Right. Sometimes people will just put the charges up here, and then they'll end up getting the complete molecular equation wrong because your molecules and your formula units here for ionic substances don't have the ions. This is neutral. These are neutral substances. So you need to make sure you don't have those little marks. Let's try another one.
Okay. So I'm going to start with that first compound, and I'm going to say, okay, that's made up of sodium ions, Na+1, and fluoride ions. I'm just writing them up here. Calcium, that's the Ca2+, and then I've got the bromide ion, it's the Br-. I'm going to switch the cations. So the sodium's going to go with the bromide ion to make sodium bromide, 1-to-1 ratio. And the calcium's going to go with the fluorine or the fluoride ion. So I'm going to have CaF2. I need 2 of those fluorides to make a neutral compound. Now I'm going to erase those little ions up there or line them out. We're done with those. And that's not part of our answer. It was just to help us. Let's balance. I've got 2 bromines on the left, only 1 on the right. And look what I did. Now I affected my sodium, and I've got 1 sodium on the left, so I better put a 2 out there. Okay, so I've got 2 sodiums, I got 2 fluorines, we're good there. 1 calcium, 2 bromines, we're balanced.
Check, check.
The next step is to find out whether or not these are soluble in using our solubility chart, because these are ionic compounds. So that first compound, my anion was the bromide ion. I'm going to look for that. There it is. It's in the soluble portion, but I have to look at the exceptions, and the exceptions do not include sodium. So that is soluble. So we mark that with an AQ. That means aqueous. That means soluble in water. Now, since we're talking about precipitation reactions, if I had to guess, I'd say that this one's probably insoluble. But let's look. The fluoride ion, I see that there. All fluoride salts, that's in the ionic or the soluble ionic category. So that's looking good. We have to look for the exceptions, and look at that. Calcium is an exception. So it is not soluble. The fluoride with calcium, not soluble. So we write an S. And that means solid. And you get using this word soluble and you think S is for soluble, but S just means solid. That's a precipitate. So this is a precipitation reaction. It's a double displacement precipitation reaction. And there's our complete molecular equation.
Okay, so to kind of just go back, you're going to be expected, if you are given two substances, to be able to perform the reaction, predict the products, balance the equation, and then determine the states of those products. So you're going to be performing a single or a double replacement reaction, and single would be you have an element and a compound, and double replacement you would have two compounds combining. You need to form neutral products from the ions that they actually produce. It doesn't matter if there's two sodiums. Sodium ion is Na+1, just one sodium with a +1. So you have to make the correct formula for the products. Then you want to balance the equation, and that's where the two sodiums would come in. You'd end up with a coefficient probably. And then you need to determine the states of matter. And we're going to be learning more about how to predict states of matter, but right now you know how to determine if it's an S or an AQ from your solubility table for ionic substances, and also knowing that all acids are soluble. Or if you were told that a molecular substance was polar, you could say that would be soluble in aqueous solution.
As always, we've got some practice here for you. So notice here, this is the first time we've seen this. We have a reactant that's a solid, and that's okay. We can have a solid reactant and put it in with a solution, and we can form products with that. So don't let that throw you off. You're going to want to predict your products, balance your equation, and write the states. So pause the video, give this a try. You're gonna want to get very comfortable with this, and
have your solubility table out.
For sure.
Here comes the answers. There you go. So I do want to point out here this first one, when we do our double replacement reaction, I have H plus from the HCl, and I have OH minus from the silver hydroxide. And when I combine those, you always put the cation first, or the positive ion first, and I end up with HOH. And that doesn't look familiar, but it really is water, H2O. And as far as we're concerned, you could write it either way, but they are synonymous with each other. In
our class, HOH is just fine.
And that is a liquid. So we're talking about room temperature. We're assuming room temperature here, that it's not an ice cube or a gas. Sometimes you'll see these as solid or liquid or gas. But if you are predicting products and you come up with an HOH or an H2O, you can assume that we're at room temperature and mark that with a little L for liquid. Thanks so much for tuning in. We appreciate it. We will see you on the next one.
Bye-bye.